In these examples, we are going to look at factoring trinomials when the a value isn't 1 at the beginning. Up to this point, everything we've factored had a leading coefficient of positive 1. So you'll notice in these examples, we don't have a leading coefficient of positive 1 right from the beginning. Let's take a look at part A, for example. So there's a couple things that you should notice about part A. It has a cubed. Everything we've done so far was usually a squared as the highest power, and now it's also leading with a coefficient of negative 1. If you look in the directions, it really reminds us to first factor out a GCF before you do anything else. So if I look at part A, and I look at every term, I notice they all share a y in common. But since my leading coefficient is negative 1, I want to factor out that negative 1. Anytime your leading coefficient is negative, you want to factor out the negative 1 so you leave yourself with a positive a value. So that negative 1 right there tells me I also want the negative 1 to be in my GCF. So now I'm going to factor out negative y. And that's going to leave behind y squared minus 4y minus 21. So notice how the signs of all three terms change, because basically I divided them all by negative 1 and put it on the outside of the parentheses. So it's going to change the sign of all your terms. Now when I go to factor, I just have to worry about factoring the trinomial that's left inside the parentheses. So I need numbers that multiply to negative 21 that add up to negative 4. So we recognize 7 and 3 are the choices, and we would want the 7 to be negative and the 3 to be positive, so it adds up to negative 4. So on the outside, we have negative y. Then we set up our skeleton for our two binomials. So this becomes y minus 7, y plus 3. That's going to be our final answer, but I'm going to walk you through the check procedure. So when we go to check, we want to multiply the two binomials first. So I'm going to leave negative y on the outside, and I'm going to multiply the two binomials using FOIL. So first I'm going to do y times y, which is going to give me y squared. Then on the outside, I get plus 3y. On the inside, I get minus 7y. So we're going to combine those like terms in our head for negative 4y. And then we end with negative 21. But that's not the trinomial we started with, because we still have to distribute negative y, the GCF. So now if I distribute negative y, I get negative y cubed plus 4y squared, and then I end up with plus 21y. And that matches the trinomial I had in the beginning, so now I know the answer that I put a box around. Now I know that's the correct answer. Let's go on to problem part B. I can see that the GCF is 2. So what I'm going to do is I'm going to factor out 2 from the trinomial. So that leaves me with a squared plus 12a minus 45. So I need factors of negative 45 that add up to 12. So I don't need to worry about 1 and 45. I know that's not going to work. So my choices are 3 and 15 or 5 and 9. We can tell 3 and 15 are going to be the choices I want, but I want 3 to be negative and 15 to be positive, so it adds up to positive 12. So my two binomials are going to be a minus 3, a plus 15. So I'm pretty sure that's my answer, but let's go through the check procedure. So again, I would multiply my two binomials first. That's going to give me a squared, then plus 15a minus 3a gives me plus 12a in the middle, and then I end with minus 45. But remember, I still have to distribute the 2. And then after I distribute the 2, I get the original trinomial that I started with. So I know that my boxed answer is correct. Let's go down to part C. My GCF is 4. So that leaves behind x squared minus 6x plus 9. So I need factors of 9 that add up to negative 6. So 1 and 9 won't work, and I want to use 3 and 3. But to multiply to positive 9 and add up to negative 6, both 3's have to be negative. So my binomials become x minus 3, x minus 3. But make sure you're leaving the negative 4 every time you write a new line. Make sure the negative 4 stays there. It's still part of your answer. We don't get rid of it. Now my binomials are the same. So instead of writing them out twice, I can write them out once with the exponent of 2. So for my final answer, I have 4 times the binomial x minus 3 squared. And finally, let's look at part D. The terms all have a 2 in common, but they also have x squared in common. Now, if you're wondering how I knew it was x squared, when all the terms have the same variable, you look at the smallest power available. So in x to the fourth, x to the third, x squared, 2 is the smallest power. So whatever that smallest power is, that's going to be the power that's part of your GCF. So my GCF is 2x squared. So the trinomial that it leaves behind is x squared minus 13x plus 42. So I need numbers that multiply to 42 that add up to negative 13. So 6 and 7 are the correct numbers. They both need to be negative because they have to multiply to a positive 42 but add up to a negative 13. So I keep my 2x squared on the outside. I never get rid of that. But then I make my skeleton for my two binomials, and I get x minus 6, x minus 7. And I'll leave the check up to you. We checked the first two. You can check part C and D on your own.